This is day 4 for the Comprehension extension. We are going to be reading a technical text. A technical text is an informational text, but it is more specific to a process, procedure, or a job, and it goes really in detail with that. So some characteristics that you want to look for, you're going to see facts, you're going to see domain-specific words, and you're going to see graphics such as diagrams that illustrate these concepts. So this is Wild Weather by Laura Townsend, and this is a technical text. What's the weather like where you are? Sunny and warm, snowy and cold? Is a storm predicted? Have you thought about the weather at all today? Meteorologists or scientists who study weather always think about the weather. They also observe, measure, and record its changing patterns. Their goal is to better predict what the weather will be, especially when storms are about to strike. So, what causes weather? When predicting weather, scientists study air masses. An air mass is a large body of air with the same properties, such as temperature, air pressure, and water vapor. A colder air mass doesn't mix well with a warmer air mass, and that can cause stormy weather. Cold air is heavier than warm air, so it pushes underneath a warm air mass. When warm air moves into a cold air mass, however, the opposite action occurs. Warm air is lighter, so it rises above the cold air. Changes in the weather occur because air masses are always on the move. The area where two air masses meet is known as a front. When a warm air mass is moving into an area, it's called a warm front. When a cold air mass moves in, that area is called a cold front. Scientists also study air pressure to predict the weather. Air pressure is the weight of air pressing down on you. High air pressure causes the weather to stay calm, but if air pressure begins to drop, watch out. This can lead to really wild weather. So on the right of this page, you see a diagram that really goes into detail and it shows you. So the red block is the warm air. You can see that the warm air is lighter, so it lists above a cold air mass. The diagram on the bottom is illustrating a cold front. So because cold air is heavier, a cold front pushes a warm air mass upward. What causes hurricanes? Hurricanes affect the weather in the United States each year. Beginning as tropical disturbances, some storms continue to gain force and size. Once their wind speeds reach 74 miles per hour, the huge rotating storms are officially labeled hurricanes. A hurricane forms over warm ocean waters. Its winds begin to circle around an area of low air pressure, creating clouds and thunderstorms. More warm, wet air gets pulled upward, causing the storm to become larger and stronger. Wind speeds build and air pressure drops, and the storm keeps strengthening because of the warm, wet air feeding it. Eventually, a dangerous hurricane is born. Pushed ahead of a hurricane, the ocean surface may rise up to 33 feet higher. These storm surges can be as wide as 100 miles and can smash into shorelines like bulldozers. If a hurricane comes ashore, it brings heavy rain, flooding, and powerful winds, causing damage to property and harm to people and animals. A hurricane may be as wide as 300 miles. It can travel thousands of miles and last for more than a week. Once it reaches cooler seas or moves across land, however, the hurricane loses its energy source, and as a result, it begins to weaken. So here we have a diagram, which is a look at a hurricane. So storm clouds can reach 8 miles into the atmosphere. The hurricane's fastest winds spiral around the eye wall. The air inside the eye is calm. And over the warm ocean, a hurricane gains strength because it pulls in large amounts of water vapor. So now we are going to answer some questions. Now, I don't know about you guys, but whenever I'm reading, I need to go back and look for the answers to the questions. So I always read something the first time to understand what I'm reading. and then I go back a second time to look for the answers. Now, sometimes it is written right into the passage. For example, if it's talking about how high do wind speeds need to reach for a tropical disturbance to be classified as a hurricane, I can read right here in the passage that once their wind speeds reach 74 miles per hour, the huge rotating storms are often labeled hurricanes. So sometimes the answers we're looking for are written in like that, where you can find it right there in the passage or in the book. But sometimes you have to use what the book is giving you and what you already know to answer the question more in depth. The first question we're going to answer is, what is the difference between a tropical disturbance and a hurricane? So we can actually use my example here. A hurricane is labeled a hurricane when wind speeds reach about 74 miles per hour. Now, tropical disturbance is just a storm that is developing. It's not classified as a hurricane until it reaches 74 miles an hour. So that is the difference. The next question is, what causes a storm surge? So I can read about the third paragraph. Pushed ahead of a hurricane, the ocean surface may rise up to 33 feet or higher. So that is when a hurricane's winds push the ocean surface in front of it, because the winds in a hurricane are so fierce. So that storm surge is all of that water being pushed to the surface. Now, that's not written directly into the passage, but I'm using what I know, and I'm using what they are saying. Pushed ahead of a hurricane, meaning it has to be pushed by the winds, because that is what is pushing in a hurricane. So we're going to go ahead and move on to the next page. What causes thunderstorms? About 45,000 thunderstorms occur around the world every day, bringing rain, wind, lightning, thunder, and sometimes hail. These powerful storms develop when air masses of different temperatures come together. So thunderstorms begin to form as warm, humid air rises rapidly. Then a cold front or strong winds push under the warmer air mass. As the rising air begins to cool, clouds take shape, heavy with water droplets and even ice crystals. Strong winds blow both upward and downward within the cloud. Finally, rain begins to fall, pulling cool air down with it. Strong electric charges build up at the bottom of the cloud, causing lightning and thunder. While violent, these powerful storms are usually over within about an hour. Because the rain and cooler air prevent warm air from continuing to rise into the clouds, most thunderstorms will move away quickly. When extremely strong thunderstorms occur, meteorologists become concerned about the possibility of another severe weather event, a tornado. Tornadoes form in less than 1% of all thunderstorms, but when they hit, they can destroy everything in their path. So, large amounts of warm air are pushed upward, forming a thundercloud. These upward movements of air, called updrafts, can reach speeds of 62 miles per hour. What causes tornadoes? A violent twisting column of air racing across the plains may be exciting to see in a movie, but few people want to see one in real life. Some tornadoes generate the fastest winds on Earth. Their wind speeds may reach over 300 miles per hour. Tornadoes form when winds spin a funnel or column of air at the base of a storm cloud. Rapidly rising air in the funnel pulls warm, humid air into it. The fast spinning air creates an area of low air pressure in the funnel's center. Due to the low pressure, air on the ground continues to rush into the funnel to join the cloud above. The swirling funnel begins to lengthen. If conditions are right, the funnel touches down and the tornado begins to move along the ground. These violent storms typically have narrow paths of destruction. Nevertheless, their routes may cover many miles. Tornadoes are more difficult to predict than other storms. However, with advanced weather tracking, meteorologists are now better able to warn people and give them time to take cover. So the diagram in the top right corner of the page is showing you how the warm air and the cool air are meeting and being pulled into the storm cloud. So sudden changes in wind direction and speed create a violently spinning funnel that may become a dangerous tornado. So as meteorologists continue to learn about weather patterns, they will be able to more accurately predict the paths that storms may take. This means less chance of loss of life and property. With better forecasting, people have more time to prepare, so wild weather doesn't have to be so scary. So now that I've taken the time to read this page and understand it, I'm going to go ahead and answer some more questions using the information that is presented to me. So the first question on this page that we're going to answer is, where is the warm air in a tornado moving compared to the cool air? Now, I can actually look at the diagram to show me what direction each temperature of air is moving. For example, when I'm looking, warm air is pointed upwards as cool air is pointed downwards. Now, in previous pages, it has been telling us that warm air has been rising. So using what we've already read on previous pages and this diagram, we can say that warm air goes up while cool air goes down. Now, the last question we are going to answer is, how can meteorologists help protect people? Now, on the bottom of the page, you can see that if they can accurately predict the paths that the storms may take, this can decrease the chance of people losing their lives and their property. So with better forecasting and quicker predictions, they have a greater chance of preparing for these storms. So again, this is an optional comprehension activity. I'm sure all of us are cooped up and we don't have much better to do. So this is just something that you don't have any activity to do with, but if you're listening to it, it's something that we would have done in class. So again, there is no assignment for this. We're just hanging in there. So again, thanks for watching. And if you have any questions about some assignments that you're not sure about, you can always ask me. Thank you.